coming up with. Then the last one is these word problems, okay? So what you're really trying to do is write the linear equation from these word problems, okay? And so I'm going to do a couple of these with you. Let's see if this one has answers. Does have answers, okay? My answers that I've made for you. So take a look at number one. Again, on this, what we're trying to do is write the linear equation. We're trying to write the relationship between two things here. So number one says, suppose that a water level of a river is 34 feet and that it is receding at a rate of 1/2 foot per day. Write an equation for the water level L after D days. In how many days will the water level be 26 feet? Okay, so once you come up with an equation, you're going to solve using the number that they give you. Okay, let's see if we can make more sense of that. So what we know is that the water level is 34 feet. So I'm going to start with that. Let me stop my share here. Okay, so 34 feet. And it is receding. So we got to think about what receding means. Is it increasing or is it decreasing? So receding means it's dropping. It's going down. So it's 34, but it's dropping. So I'm going to put a minus at a rate of 1/2 foot per day. So it's dropping 0.5 feet every day. So I'm going to attach that to a D, 1/2 foot every day. Okay, so after one day, if we put a 1 here for D, then it's dropped 1/2 foot. After 2 days, if I put a 2 for D, it's dropped 2 times 1/2, which is a whole. Okay, and so here is an equation that kind of matches this situation. And what we know is this is equal to the level. The level is equal to 34 minus 1/2 foot for every day that goes by. So that would be an equation for your first problem. Now they want us to actually use that equation and solve for a problem. So let's go back to the problem. In how many days will the water level be 26 feet? How many days water level 26 feet? Okay, so I need to put this 26 in to my equation and solve for the other. Now notice the question is asked how many days. So I'm trying to find my D, how many days? Not to mention the fact that it says the water level 26 feet. L stands for level. So I'm going to take 26 and put it in for the level. And now I'm just going to follow my algebra, okay? So we're trying to solve for D, isolate the variable. So got to get rid of this 34. Subtract 34, keep it balanced. Subtract 34 from the other side. And so we end up with a -8. Bring down. Make sure you bring your minus sign as a negative. Negative 0.5 D is equal to -8. Last step. This means multiply, so we undo it with division. That leaves D. Keep it balanced. 8 divided by 0.5 is 16. A negative divided by a negative is a positive. Okay, so think about what this means. What is D? D is days. So after 16 days, the water level is going to be at 26 feet. Okay, that's an example of a linear equation. How the level of the water is totally dependent on the number of days that have went by, right? So they are related. We could have, instead of using L and D, could have used X and Y, which is what we've kind of been working on, is X and Y, but the variables don't matter. All right. Let's look at number 3. For babysitting, Nicole charges a flat fee of $3 plus $5 per hour. Write an equation for the cost C after H hours of babysitting. What do you think the slope and the y-intercept represent? How much money will she make if she babysits 5 hours? Okay, so let's start by trying to write an equation that represents how much money she makes. But remember, how much money she makes depends on how many hours she babysits. So they're related to each other, okay? So she charges a flat fee of $3 plus $5 per hour. So no matter what, no matter how many hours she works, she's getting $3 up front plus $5 per hour. So I'm going to write that out as $3 plus $5 for every hour. Okay, this represents the cost for her to babysit. It's going to be $3 plus $5 times the number of hours. So as the hours go up, so does the cost. Okay, so this would be a good equation for her to have to give to people, so they can figure out how much it's going to cost for her to babysit. Okay, it asks about the slope and the y-intercept. If you want to try and find it, that's great. You might you're going to have to do it from a table. You don't have a graph here. And how much money will she make if she babysits 5 hours? So let's figure that out. Okay, so I'm going to go ahead and make a table. So her cost is totally dependent on her hours. Okay, and so let's start with what they came up with. So 5 hours. If she babysits 5 hours, what will the cost be? So put a 5 in for hours. 5 times 5 is 25, plus the upfront cost of 3 means the total cost would be $28. Okay, what about 7 hours? 7 times 5 would be 35 plus 3, 38. How about 10 hours? What if she babysits all day long? $10 times $5 an hour is 50 plus 3, $53. Okay, so we already answered the question of how much money will she make if she babysits 5 hours. She's going to make $28. But we've also come up with a couple other examples so that maybe we can figure out what the slope and the y-intercept is. Okay, so let's start with the slope, and we're just going to use 2 of these points. I'm going to just take these first 2. Okay, so the slope, y2, 38, minus y1, 28, over x2, 7, minus x1, 5. 38 minus 28 is 10. 7 minus 5 is 5. Last step, simplify. 10 divided by 5. I'm sorry. 7 minus 5 is 2. And 10 divided by 2 is 5. Okay, so the slope is 5. Slope is 5. And the y-intercept, remember that's where on the y does the line cross when x is 0. So remember, this is x and y. So when x is 0, when this is 0, what's y? 5 times 0 is 0 plus 3. So the y-intercept is 0, 3. And so what I really want you to notice, and I'm going to kind of touch on this in the next video, is our slope is 5. Notice that's in our equation. And our y-intercept is 0, 3, which is also in our equation. Okay? And so there's a certain way we can start to read these equations that we can pull things out of them that up to this point we're just solving for. Okay? Let me go back to this. go ahead and give these a try. They're all pretty similar. Again, there are answers in the back, but what I really want you to get is the big ideas, which is, what is a linear equation? So a linear equation is an equation that shows a relationship between two things. As one changes, so does the other, okay? And I also want you to remember that we can use a function table or an in-out table to come up with just certain examples that follow that relationship, okay, at the beginning. So if you remember at the beginning, we talked about the relationship between my age and my brother's age. I'm 3 years older than him. I will always be 3 years older than him. But as my age changes, so does his. And so, so just keep those big ideas in mind. As I said before, we're using the coordinate grid. We're using slope, which is what we've been working on this week. And now we're talking about linear equations. They are all related to each other. They all use each other, and they're connected, okay? So I'm going to keep connecting the dots. We're going to really kind of dissect specific parts of linear equations in the upcoming videos, but try these worksheets. I know I'm hitting you hard this week. I don't expect that you're getting all this in one day. It's probably going to take several days to kind of work through this and make it make sense. But I'm here if you need me. Let me know, email me, text me, send me a message on YouTube, whatever. And you don't necessarily have to be one of my students for me to answer your question, because if you have a question, probably somebody else does too. And so give me comments if something doesn't make sense. I'm going to try my best. I hope this video worked out. It's been interrupted many times because of a lack of connection. So hopefully it still makes sense, but I don't know. If it doesn't, then I guess I'll redo it. So I hope you all are doing well and staying healthy, and I will talk to you soon. Take care.